Okay, hello students. Welcome to today's Friday Happy Math Hour. Today's topics are going to be probabilities, permutations, and combinations. Okay, now I believe last week I did the introduction to probabilities, but I'm gonna go over it briefly again. Okay, but today's main concepts will be basic concepts of probabilities, multiplication principles, permutations, and combinations. So this is what I covered last week, okay? It's important for me to recap on this because this leads to section 8.4. Okay, now, introduction to probabilities. We have to find the random experiment, a process by which we observe something uncertain. After the experiment, the result of the random experiment is known. The sample space is denoted by S, the set of all possible outcomes of the random experiment. Here, for example, examples of sample space. If you flip a coin, right? If you flip a coin, it can either be heads or tails. So the sample space will just be heads and tails, H for heads and T for tails. If you roll a third die, right, like a die, the sample space will be 1, 2, 3, 4, 5, or 6, because a die is like a cube, right? And every side has a number from 1 through 6. So the sample space will be 1 through 6. Okay, now at times it's easier to draw a tree diagram in order to find the sample space. For example, find the sample space of flipping a coin twice. Right, so the first, if you toss it, the first, it can be either a heads, right, or a tails. That's my first flip. It either can be heads or tails. Now my second flip, if it was heads first, then it can be heads or tails. If the first toss was tails, then after tails, it can be heads again or tails. So my sample space, all we do is follow the lines here. So the sample space will be heads, 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 tails, tails, heads, and tails, tails. So that's my sample space. And the sample space, you have to put it like with the brackets, right? That means it's a set. It can be HH for heads, heads, H tails, HT for heads, tails, TH for tails, heads, and TT for tails, tails. Now, an event is an outcome or a set of outcomes of a random experiment. An event is a subset of a sample space. For example, if the sample space for flipping a coin is heads or tails, then one event, which denoted by E, is equal to H, which is heads. That's one event, which represents the outcomes heads. Okay, now checkpoint. Suppose a die is tossed. Write the events in said notation. The number showing is less than 3. Right, so this is my sample space. So a die showing less than 3 is going to be the 1 and the 2, not 3 because it's saying less than 3. So the answer will be the set of the elements 1 and 2. Okay, that's my event. Now for B, the number showing is a 5. So there's only one 5, right? So the event will just be a 5, the set with a 5. For C part, the number showing is an 8. That's going to be the empty set because there's no 8 on the set 1, 2, 3, 4, 5, 6. So it's going to be that symbol like with a circle with a line over it, or just a bracket with nothing in there. The number showing is even, right? So from there, the evens will be 2, 4, 6. So that's my event, 2, 4, 6. Okay, now all that is leading to basic probabilities. The formula for basic probabilities is P of E, the probability of the event, equals to N of E over N of S. The N stands for the number, not the number of the event over the number of S, over the sample space. Okay, so there it is. Okay, now, checkpoint. Suppose a single third die is rolled with the sample space S equals to the set with elements 1, 2, 3, 4, 5, and 6. Give the probability of each of the following events. Okay, solution, right? For A part, The die shows an even number. So it's going to be 3 elements, right? It's a 2, 4, and 6. So N of E is 3 and N of S is 6. So it's going to be 3 over 6, which is equal to 1/2. Now for B, F, the die shows a number less than 10. So then a number less than 10 will be all 6. It will be 1, 2, 3, 4, 5, 6. So there will be 6 elements. So N of E is 6 and N of S is 6. So 6 over 6 is equal to 1. So that's like 100% or 1. For C, the die shows an 8, right? There's no 8 on the set 1, 2, 3, 4, 5, 6. So it's going to be 0. So 0 over 6 will give us 0. So there's no way we can get an 8 because there's no 8 on the sample space. Okay, now this continues. I believe I also went over this last week, which is good to review. Okay, now checkpoint. A single playing card is drawn at random from an ordinary 52-card deck. Find the probability of the drawing. A queen, B, a diamond, C, a red card, and D, a face card or an ace. So here's what the cards look like, right? There's going to be 13, these are called suits, like the suit of diamonds, suit of hearts, suit of spades, and suit of clubs. There's 13 on each suit, 13 clubs, 13 spades, 13 hearts, and 13 diamonds, which is a total of 52. Okay? Now, there's 26. Black was right because 13 plus 13 is 26. The clubs and the spades are black, and there's 26 reds. There's also 3 face cards for each suit. What are face cards? A face card is a card that has a face on it. For example, these are called face cards. If you notice, every suit has the jack, the queen, and the king. For example, the suit of clubs has the jack of clubs, the queen of clubs, and the king of clubs. The suit of spades has the jack of spades, queen of spades, and king of spades. Same thing with the hearts and same thing with the diamonds. Now, let's answer our questions here. Okay, let's answer the probabilities. So this is a formula we're using. So every time that it says probability, this is the formula that you have to use. The sample space is 52 again because there's 52 total cards. So for it to be a queen, how many queens are there in the deck of cards? There's going to be 4 queens, right? Because there's 1 for each suit. So there's 4 queens in the deck of cards. So 4 over 52 because that's my sample space. So right, we have to reduce it. So it's going to be 1 over 13 is your answer. Now B, the probability of a diamond, right? So how many diamonds are there? There's going to be 13 diamonds. It's going to be 13 over 52, which will give us 1/4. Okay. A red card. A red card, there's 26 red cards, right? Because there's 13 hearts and 13 diamonds, which are red, which will give us 26. So 26 over 52, the result is 1/2. Now for D part, a face card or an ace. How many face cards are there? There's 3 of each suit, so 3 times 4 is 12. Right? And how many aces are there? There's going to be 4 aces because each suit has an ace. The ace of diamonds, the ace of hearts, the ace of spades, and the ace of clubs. So plus 4. All over 52. That'll give us 16 over 52. Then we reduce it. The answer is 4 over 3. That's how we do these type of problems. But if you do on the homework, these examples can help you with the homework because the homework has questions very similar to these right here. Okay, now here's another example. Assume that the probability of a couple having a baby boy is the same probability of a couple having a baby girl. If the couple has 3 children, find the probability that at least 2 of them are girls. So for the sample space and for a visual, it's easier to draw a tree. Okay, here we go. Having 3 children, right? So this is a first birth. It can be a boy, right, or a girl. Now let's go to the second birth. Say that the first birth is a boy, right? Then after the boy, it can be a boy or a girl again. If the first birth was a girl, then after the girl, it can be a boy or a girl. Now, if the first baby was a boy and another boy, then after that boy, it can be a boy and it can be a girl. If it was a boy and a girl, then it can also be a boy and a girl. You see, after this, I believe you should get the pattern right, so it can be also a boy and a girl. And if it's a girl, it can also be a boy and a girl. So then this is your sample space, right? So we have to be for it to be like visual, so we can see it. So it can be boy, boy, and boy. It can be boy, boy, and girl. It can be boy, girl, boy. It can be boy, girl, girl. And if it was a girl first, the first birth, then it can be a girl, a boy, and a boy. It can be a girl, a boy, and a girl. It can be girl, girl, boy, and all girls, girl, girl, girl. Now, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So my sample space is 8. Okay, now what does the word at least 2 of them mean? At least 2 of them are girls. At least 2 means there have to be 2 or more, right? 2 or more. So let's go to the first one, boy, boy. So the first one's not it. So let's go here to the second one. That means 2 more. No, it's not it. So we start here. That's my first choice. Girl, boy, boy that's not it. Now girl, boy, girl is one of part of the answer, and also girl, girl, boy. You can say it means 2 or more, so it's gonna be 2 or 3. So this is my result. So it's gonna be 4. So 4 over 8 will give us 1/2. So the probability will be 1/2. And again, on your homework, you have something very similar to these, but the question, the probability might be a little bit different. It can be at most 1 boy, at least one girl. Stuff like that. So with this example, you'll be able to answer some of the questions on the homework. Now, I also believe I went over this one on last week, but this is crucial to answer some of the problems that are in your homework. Okay, so this is what we're going to be doing for 8.4, which is basic concepts of probability. The addition rule for probability. For any events E and F from a sample space S, this is your formula. To find the probability of E union F is equal to the probability of E plus the probability of F minus the probability of E intersects F. Okay, now let's do example number 1 here. And I believe also there's the first few problems from this section from the homework, they have to do with a relay table. So you can use this example to answer. I believe it's like the first 4 or 5 problems on your homework. Okay, now let's explain what the relay table is, right? And what's in there. It says here, when playing American roulette, the croupier, which is the attendant, spins a marble that lands in one of 38 slots in a revolving turntable. The slots are numbered 1 through 36, with 2 additional slots labeled 0 and 0 that are painted green, right? Which are these right here, the green, the green slots. This is supposed to be half of the remaining slots are colored red and half are black. In roulette, the slots labeled 0 or 00 are not considered as even or odd. Now here's what we're looking for. Find the probability that the marble will land on a red or even. Okay, so how are we going to do this? Solution. Hey guys, here guys, I already put all the red numbers. I already put in here, right? I already went over to the whole roulette circle, and I got all the red numbers. These are the red numbers. Okay, so we're going to let the set of red be R. So R stands for red. Now we're doing right. It says here land on a red or even. Now these are the even numbers from the roulette table. So all these are even. Okay, now, so this is my formula, right? So we're trying to find red, right? It says red or even. That's why this is a formula we use, because the U stands for or union. That's why the key word is red or even. So we know this is a formula that we're using. So then we have to go to the right. So the totals are 38. Again, if we count them, there's 18 red and 18 black, because there's 38 total, and two of them, they're not considered even or odd. So these are the ones that has the 0, 0 and the 0. Those are not included here. That's why it's going to be 18 red and 18 black and 18 even and 18 odd. So from the red, there's going to be 18. Right? And also this is where they intersect. Right? Red and even. So red and even are here. These are red and even. So there's 1, 2, 3, 4, 5, 6, 7, 8. That's why it's going to be 8. That's where they intersect. So here we go. So this is going to give us 8 over 38, because there's 18 red and the sample space is 38. Plus, right, there's also 18 even. So it'll be 18 over 38, because 18 are even. Minus, right, where they intersect, where there's red and even, are the 8 here, the 12, the 14, 16, 18, 30, 32, 34, 36. Those are red and even. So it's going to be minus 8 over 38. So this is your solution, because 8 minus 8 is 10. 10 plus 18 will give us 28. So this is your solution, guys, but all we do is simplify it. The answer is 14 over 9. I believe this example will help you, like I mentioned earlier, with the first few of the homework. Okay, now, example 2. Suppose two fair dice are rolled. Find each of the given probabilities. The first die shows a 2, or the sum of the result is 6 or 7. Okay. Here's my solution here. Again, we're going to use the same formula. So let A represent the event that the first die shows a 2, right? Because that was first. So this is A, the event A. We're going to let B be the event that the sum is 6 or 7. This will be event B. So here's a drawing, right? I mean, here's like a visual. So for the first one, right, the first die shows a 2 is here, like in red. You see, the first die is a 2, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. That's event A. And event B will be in blue, right, because it says that's 6 or 7. So this is 6 or 7, right? You see all these add up to 6, the dots, and these add up to 7. But the sample space is 36, right? Because 6 times 6 is 36. That's my sample space. Right? There's going to be 6 of them here. 1, 2, 3, 4, 5, 6. So N of A is 6, and N of B is 11, because if we count them, we have 2, 4, 6, 8, 10, 11. So, right, so this is my formula. So P of A, right, is going to be 6 over 36. P of B will give us 11 over 36, minus the probability of A intersects B is what they have in common, right, or where they intersect. So it's going to be the 2, 4 and the 2, 5. So it's going to be 2. So it's going to be 2 over 36. So we do our math. 1636 plus 11 over 36 minus 2 over 36. The result will give us 15 over 36. Simplify it. The result is 5 over 12. This is the answer for part A. Now for part B, the sum is 11, or the second die shows a 5. So let's do here, guys. So the sample space is 236, right? There's my formula. So we're going to let A represent the event that the sum is 11, because that's first. So 11 will be these two here, right? So this will be 11. They add up to 11. So N of A equals 2. Now let B represent the event that the second die shows a 5. So the second die is a 5, so it's going to be all these right here, right? Because the second die is a 5. So how many are there? There's going to be 6. Now, where do they intersect, right? Where do they intersect? They intersect right there. So it's only going to be 1. So now let's go back and plug the numbers to the formula. There's going to be 2 over 36 plus 6 over 36 minus 36. And the result will be 7 over 36 is your final result. That's your answer. Okay, now let's move on. This is called the complement rule. It says here, for any event E complement is equal to 1 minus P of E. And P of E equals to 1 minus the probability of the complement. Because instead of complement, I like to say not those, okay? This is the observation. How do we come up with a formula? Right, so this is the probability of the event, like odds in favor. Right, so it's going to be N of E over N of S over N complement of E over N of S. Right, if you notice, the N of S, they're going to cancel. That's why it's going to be N of S over N. I'm here, right? So let's see, here's right. So this becomes N of E over N of S. The division becomes multiplication. So the second one, the second fraction, we flip it. It's going to be N of S over N of E. If you notice, they cancel. So this is what we do, right? N of E over N of not E. So this is how we do the odds in favor. When we can go from here. That's why this is the answer, guys. We went from here to there, right? And I show you the proof. Now, why is that important? Okay. This is number 27 from page 434. It says, a marble is drawn from a box containing 3 yellow, 4 white, and 8 blue. Find the odds in favor, right? This is for odds in favor. And drawing a given marble, a yellow marble. So what is it? Odds in favor of drawing a yellow, which is yellow over not yellow. That's what that means over here, the observation. The probability of the event and the probability of not the event. So it'll be yellow or not yellow. So how many are yellow? The answer is 3. How many are not yellow? It'll be 12 because the white and the blue are not yellow and they're equal to 12. Right, so it'll be 1/4, but this means a notation for odds in favor. You're going to put odd, colon, 4. This is what they want. Let's do B. A blue marble, right? The odds in favor of drawing a blue. So it's going to be blue over not blue. How many are blue? There's 8 blue over 7 not blue. The answer is 8 to 7. So this is a solution at the one in green. 8 to 7. That's how you say the odds in favor. And finally, for a white marble, the odds in favor in drawing a white will be white over not white. There's going to be 4 white and 11 not white. So it's going to be 4 to 11. This is your result. Okay, now this will help you with 47 to 54 on page 442. It's because they changed editions. They went from the, I believe, from the 12th to the 30th edition. This problem here was from the 12th edition, right? And now on the 30th edition, they have something a little bit different. Okay, but it's still the same concept. Okay, now let's do this. Let's try to work this one out. Okay. Here we go. It says number 47 states it's a full-time worker. By the given chart here, it says this is the hours worked in the last week. This is the labor force status. These are full-time workers, part-time workers, and the total. Okay. So then, if you notice, the sample space will be 1591. Now, for a full-time worker, right? So we go here, the full-time worker is going to give us 1271. So 1271 workers are full-time workers. So the probability will be 1271 over 1591. Approximately like 0.7989. Now number 48, a part-time worker. for a part-time worker, right, there's going to be 320. So 320 over the sample space, which is 5091. We use a calculator, and this is my result, 0.2011. Okay, now let's continue with number 49. Work 50 hours or more. So 50 hours or more, right? It's going to be 393. Here's 50 hours or more, so we go down 393 over the sample space, which would be 393 over 5091. It'll be about 0.2470. Number 50. Work between 0 and 19 hours. So 0 and 19 hours is here on the first column. So we go all the way down, so it'll be 106. 106 over the sample space, which will give us 106 over 5091, approximately 0.0666. That's your result. Now let's do number 51. 51 says a part-time worker, and so that's crucial there, guys. Right? The and word. So it'll be 5091, right? So my sample space, right? So here, the and word, right, is crucial here, which means the part-time worker and someone who worked 40 hours or more. So here we go. So part-time worker, right? Part-time worker, which is going to be 320, right? 320 here, guys. So there's going to be, this is here, part-time worker, and work 40 hours or more. So it's going to be these two here, guys. So it's going to be 49 plus 21, which would be 70 over 5091, because it's where they intersect. So 40 hours or more are these two here. That's why it's going to be 49 plus 21 over 5091. So this is your solution. Now, number 54. A part-time worker or someone that worked 20 hours or less. So the key word here is or. Okay, so we're going to use this formula here. But if I want to, I can do it this other way, right? So let's see here, part-time workers is going to be, this is part-time worker here, right? So it's going to be this one here. So it's going to be 320, or means, right? So it's going to be 20, and then or 20 hours or less are going to be these two categories here. So these two guys, right? So we're going to add these two, which is the total. But we have to subtract these two because I already counted them on the 320, so I don't count these twice. That's why it's going to be the 106 plus 129 minus the 77 and 87 because I already counted it on the 320. But with the formula, I believe it's going to make better sense. So let A represent part-time workers and let B represent the 29 or less worked hours. Yes. Hey guys, could you hold on a minute? Someone's at the door. I'm sorry about this. Hold on. Okay, sorry about that, guys. Okay, I apologize. So here for the formula, right? So N of A will give us 320 because those are the part-time workers. Then N of B, which is the workers that work 20 hours or less, are going to be here the first two columns. So it's going to be 106 plus 129. And then for the both intersect will be the 77 and 87 because here are the part-time workers, right? And then where they intersect with 29 hours or less will be these two numbers here, which is 77 and 87. That's why, guys, it's better to use this formula here for a better understanding. So this will give us 391 over the 5091, which runs off to 0.2458. Okay, now this is something from 9.2. This is called the multiplication principle. It says suppose n choices must be made, with m1 ways to make choice 1, m2 ways to make choice 2, and then you continue until you see all the choices which is represented by mn ways to make n choices. Okay, now then there are m1 times m2 times m times dot 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 times mn. Okay, let me show you an example because this is a little bit confusing to understand it, right? But let me show you how simple it is. This is number 24 from page 477. It says here, how many different heating cooling units are possible if a homeowner has 3 choices for the efficiency ratings for a furnace, 3 options for the fan speed, and 6 options for the air condenser? Okay, here we go. By using the multiplication principle, it's going to be the number of choices for efficiency ratings of furnaces will be 3. The number of choices for the fan speed will be also 3. And the number of choices for the air condenser will be 6. So by using the multiplication principle, all we do is multiply 3 times 3 times 6, and that's my result will give us 54. This is how we use the multiplication principle. So there's 54 different units are possible. Okay, now let's continue using the multiplication principle. This is actually number 28 on page 484. This is the question here. The United States Postal Service currently uses 5-digit zip codes in most areas. How many zip codes are possible if there are no restrictions on the digits used? And how many will be possible if the first number could not be a 0? Okay, so there's 5 choices, right? There's 5 digits. And the digits, right, has no restrictions. There's 10 digits that make all the numbers. So for the first part, with no restrictions, how many digits can go in the first slot? So it's going to be 10. Right? How many can go in the second slot? 10, because there's no restriction. And 10, and 10, and 10. Because, like I'm saying, there's no restrictions. So you multiply those out, and the answer will be 100,000 different ways. Now look at part 2. How many would be possible if the first number could not be a 0? So if this first number could not be a 0, right, it can be any number 1 through 9. So it's going to be 9. And then times 10, times 10, times 10, times 10. You multiply them out, and you get 90,000. This is, again, an example of how to use the multiplication principle. Now, this is number 30 on page 484. This is again from the homework. For many years, the state of California used 3 letters followed by 3 digits on its automobile license plates. Okay, so let's do it. So there's 26 letters are in the alphabet, and 10 digits make all the numbers. So here we go, right? So we're going to have 3 letters followed by 3 digits. So let's go here, right? So here, guys, there's also no restriction, right? So it's going to be 26 times 26 times 26 times 10 times 10 times 10. You multiply them out. So we're going to get 17,576,000 different ways, different arrangements with this type of question here. Now let's do part B. When the state ran out of new numbers, the order was reversed to 3 digits followed by 3 letters. How many new license plate numbers were then possible? Right, so they reverse it, right? So the first are digits, and the second 3 are letters. If you notice, guys, it doesn't really matter because there's no restriction. All he did was do the digits first, followed by the 3 letters, which would be 10 times 10 times 10, and 26 times 26 times 26. We're going to get the same answer as we did in part A, which is 17,576,000. Now for part C, it says here, several years ago, the number described in part B were all used up. The state then issued plates with 1 letter followed by 3 digits and then 3 letters. How many new license plate numbers will be arranged? Will this arrangement provide? So all they did here, guys, was just add a number in front. right? I mean a letter. I'm sorry about that. A letter in front. And then the rest will be 3 digits followed by 3 letters. So there'll be 26 times 10 times 10 times 10 because there's no restriction. All they did was added another letter in the front, and it's going to be 26 letters, 26 and 26. You multiply it out, and you get 456,176,000. Imagine, guys, with adding one letter to part B, you increased it by what? By over 400 and almost 440,000 increase just by adding one letter. Okay. Okay. Now we're doing factorial. Okay. Factorial means right, and factorial means you're going to go n times n minus 1 times n minus 2 times dot 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 times 3 times 2 times 1. And by definition, 0 factorial is equal to 1. Okay, let me show you what that means. For example, 4 factorial is the same thing as 4 times 3 times 2 times 1. You multiply them out and you get 24. Now B, 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1. You multiply them out and you get 720. 1 factorial will just be 1. Now how about 6 factorial divided by 4 factorial? So 6 factorial will be 6 times 5 times 4 times 3 times 2 times 1. And 4 factorial will give us 4 times 3 times 2 times 1. 1 divided by 1 is 1. 2 divided by 2 is 1. 3 divided by 3 is 1. And 4 divided by 4 is 1. So we got 6 times 5 times 1 will give us 30. Okay. Now these are called permutations. A permutation of a set of elements is an ordering of elements. For instance, there's 6 permutations. There's 6 permutation ordering of the letters A, B, and C. Okay? For example, A, B, and C can be rewritten in 6 different ways. ABC, ACB, BAC, BCA, CAB, and CBA. The order matters. For example, ABC and CBA are 2 different orders. Okay, for permutations, the order matters. Example, how many batting orders are possible for a 9-person baseball team? Right, there are 9 possible choices for the first batter, 8 possible choices for the second batter, and so forth, all the way till you get to the 9th batter. Right, so then, or this is equivalent also to 9 factorial. Right, you see 9 factorial, same thing. Okay, and the answer will be 362,880. Now, permutations, this is another way to do permutations. It's called the NPR. And here, guys, the order matters. The formula for permutations will be n factorial divided by parentheses n minus r factorial. Okay, now, I have 3 letters, A, B, and C. I would like to know how many 2-letter arrangements are possible. Okay, here they're right. It can be AB, it can be BA, it can be AC, it can be CA, it can be BC, and CB. So it's going to be 6 different orders that you can order from 3 letters, order them in 2-letter arrangements. Okay, now let's apply the formula here. Right? So it's going to be 3P2. So it's going to be 3 factorial over 3 minus 2 factorial, which results in 3 factorial over 1 factorial. Is going to give us 3 times 2 times 1 over 1 will give us 6. The answer is 6. Okay, now. Or we can do the multiplication principle. Right? You have 3 letters, right? And you want to arrange them in 2. So you're going to go 1, 2. How many can go there? 3 on the first lot. If one's already chosen, then we have 2. You see, guys, if you notice, we're going to get the same thing every time for here on the numerator, 3 times 2. The answer is 6. Let's do number 40 on page 485. This is from a cooler with 8 cans of different kinds of sodas. 3 are selected for 3 people. In how many ways can this be done? Right, so it's going to be N, and the NPR, the permutation. So it's going to be 8 permutation 3. So it's going to give us 8 factorial over 5 factorial. So 8 factorial will give us 5 times 4 times 6 times 5 factorial. You see the factorials will cancel to 1. So the answer will be 8 times 7 times 6. The answer is 336. Or you can do it another way. You have 8 cans, right, and 1 to arrangement of 3. So how many arrangements? 3. So you're going to put slash, 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 right? So it's going to be 3, right? So this is the first arrangement times the second times the third. So, right, so if there's 8 cans of different kinds of soda, right? So if somebody picks one, how many choices do they have to choose from? The first person is going to be 8. So one of the sodas has already been picked, right? So then there's going to be 7 left for the second person, and then there's going to be 6 left for the third person. And like I repeat, like I did earlier, right? The 8 times 7 times 6, it will always be the same thing as here on the permutation, 8 times 7 times 6. So the answer will be 336. Now comes combination. For combination, the order does not matter. Right? Let's have the same arrangements as the previous example for the permutation, right? We have 3 letters, A, B, and C. Now we'd like to know how many 2-letter groups are possible. Order does not matter. For example, AB and BA is the same thing. That's why we only put it once. We have AB, AC, and BC. The answer is 3. Let's use a formula, right, to prove this. So it's going to be 3 combination 2. So we have 3 factorial over 2 factorial times 3 minus 2 factorial. It's going to give us 3 factorial over 2 factorial times 1 factorial. Will give us 3 times 2 times 1. And that's a 3 factorial. On the denominator, the 2 factorial will be 2 times 1. And the 1 factorial will just give us 1. So the answer will be 3 over 1. The answer is 3. That's how we got the 3 possible groups. Example. This is number 46 on page 485. This is 4 items. 4 items are, it says here, 4 items are to be randomly selected from the first 25 items on an assembly line in order to determine the defect rate. How many different samples of 4 items can be chosen? So it's going to be 25 combination 4. Right? So this will give us 25 factorial over 4 factorial times 25 minus 4 factorial will give us 25 factorial over 4 factorial times 21 factorial. Give us 25, 24 times 23 times 22 times 21 factorial, right? So these, the factorials cancel, that 21 factorial, that will be equal to 1, right? 4 times 3 times 2 times 1 will give us 24. So the answer will be 25 times 23 times 22, which results in 12,650. Okay, now to sum up permutations and combinations, right? Here are the 2 words that would tell you it's going to be a permutation. The words are arrangement, schedule, order, and order matters. This will be a permutation. For the 2 words for a combination is group, committee, set, sample, and order does not matter. It means there's going to be a combination. Okay. Okay, now number 59 from page 486. It says a lottery game requires that you pick 6 different numbers from 1 to 99. If you pick all 6 winning numbers, you win $4 million. Okay, let's do 8. How many different ways are there to choose 6 numbers if order does not matter or order is not important? Right? So if order is not important, that means it's going to be a combination. So it's going to be 99 combination 6. And this is my result, which is 1,120,529,256. For part B, how many ways are there to choose 6 numbers if order matters? Order matters means, right, is going to be a permutation. So it's going to be 99 permutation 6. Also, guys, this can be also done in the calculator, guys. The combination and permutations. I believe I showed my students this week how to put it in there. But anyway, guys, look at the difference here look at the difference between these two, a combination and permutation. This is like 805 billion more, right? Because this is 806 billion, 781 million, 64,320. Now this is number 60 on page 486. It says, if you pick 5 out of the 6 numbers correctly, you win 5,000. And how many ways can you pick 5 of the 6 winning numbers without regards to orders? That means combination. Okay, so 5 out of 6 will give us 6 combination 5, right? But remember, to pick the lottery, we have to pick 6 numbers of 99. So this is the ones, right, that are losing numbers. So 1 out of 93 are losing numbers because 5 out of 6 are winning numbers and 1 out of 93 are losing numbers. So this will give us 93 combination 1, right? You notice, right, this is a total, which will be the 6 and 93 will give us a 99. And 1 plus 5 is 6, right? This will be all the lotto numbers that you choose from. It will be 6. You do 6 combination 5 will give us 6. 93 combination 1 will give us 93. Multiply them out, and you got your answer, 558. Okay. Now this is number 58 on page 486. It says a financial advisor offers 8 mutual funds in the high risk category, 7 in the moderate risk category, and 10 in the low risk category. An investor decides to invest 3 at the high risk funds, 4 at moderate risk funds, 3 at low risk funds. How many ways can the investor do this? Solution, right? We have to read the problem carefully. Here, order does not matter, so it's going to be combination. So let's get the high risk first. So it's going to be 8 high risk, and we want to get 3, right? So it's going to be 8 combination 3. For the moderate risk, there's 7, and we want to get 4. So that's going to be 7 combination 4. And for the low risk, there's 10. We want to get 3 in groups of 3. So it's going to be 10 combination 3. Multiply them out. 8 combination 3 will give us 56. 7 combination 4 will give us 35. And 10 combination 3 will give us 120. So 56 times 35 times 120 will give us 235,200 different ways that this can be selected. I believe I gave you like an overview of everything for this week, and I believe that was the last slide. I wanna say, if you have any questions, please let me know. But if not, thank you for joining today's Friday Math Happy Hour. Any questions? Let me go back. Let me stop sharing.
Thank you, Mr. Isarsi, for this amazing presentation. For the next week, for Math 13, 14, and 13, 14, we have the final exam review. Thank you, everyone, for coming today to Happy Math Hour. If you have any questions, please let me know. Or if you don't have any questions, have a great weekend. Thank you, Mr. Isarsi.
Thank you, guys. Thank you for being there for me every week after week. Thank you.
You're welcome.